Our five senses, they are maybe not as easy to calibrate as many machines that we use in industry, but they are a resource we should not overlook. Hello, I'm Tom. Welcome to my channel where we talk about continuous improvement in an industrial setting. And this video is about human senses and specifically about how we can use our senses in industry and product testing and basically really integrate it into our processes. And that is because way too often I hear that when you really want to measure something, you need to put a machine there, you need to put a measuring device, you need to do laboratory analysis, it has to be chemical, optical, it has to be done with a standardized machine, because as long as you have operators or quality department tasting or feeling or checking your product, you just cannot standardize it and you will not get repeatable, reproducible results. And that is just wrong. In fact, our senses are very good and they can be, for specific measurements, be a lot better than we can do with machines. So technology is trying to catch up and we've got this artificial nose and stuff like that. But when we are measuring things like weight and length and even things like what wavelength light has, what you keep it to machines, although that last one, we'll get back to why you also want to keep it with people. But things like length and weight, we are just not that good at it. And you will also see, carnival, lottery type of things where you guess how many marbles are in the big jar, or a fair where everyone can just, guess how heavy a bull is and stuff like that. In fact, two nice things we can draw from that. First is, we do this because it is not so easy and we have got measurement devices that can do it much more accurately. But the second thing, which is actually quite interesting as well, is that the average of a whole group of fairgoers generally is quite good. So there is something to say for it as well. But in general, these easy to measure measurements, these units, leave them to the machines we have. But there are also things that are much more difficult to measure. And now maybe me being in the food industry gives me a specific view on this, but sensory testing, with which we basically mean tasting a product, that is something you really want to keep with people. But even such things as checking consistency of a product or color of a product, you have specific devices that can do this, and there's this whole field of rheology, which is basically checking all kinds of shear and viscosity type of aspects of a product, of a material. This is a very difficult physics type of subject, and it is pretty difficult to really get that into practice. So what you usually see is, for instance, in a cookie factory, it is still your tasting panel and marketing together with product development that decide on how a cookie should crack. But maybe you've seen the videos or documentaries about it, and if you haven't, go check them out. They are very interesting, they're very nice to see. But there are these machines that slowly push down on the cookie, and then there's 2 bars and 1 bar in the middle, and until it snaps, and it registers the sound sometimes, but always the force it took to crack it, how far it went over its dead point, things like that. But actually, that is not how you start up the whole process. And this is because, so why are these marketing and product development people in there, these sensory panelists? They are there because what the machine tells us is actually not the most important thing for the product. The most important characteristic is also sensed by humans. And this really is the second reason. So if your equipment is not so good at detecting specific changes and really measuring it, go to humans, and we'll really get back to that. The other thing is, if humans, and especially human senses, are your customer, then that is also how you want to test for these characteristics. Now, if you can standardize part of this testing by doing it in machines that indeed usually have a much better reproducibility, then that is great. But you will see in 90% or more of these cases that it becomes a double effort. So you combine machine data with human sensors, people cracking, tasting, checking the qualities of a product. So when you are making something for human senses, always have people check it. Now that gets us to, but can you standardize that? So when you have your 3 people or more, how do you know that they see the same today as tomorrow? And how do you do something with it? You know, if they give slightly different answers, what to do with it? To what extent can you actually trust your humans to do your sensory, to do your checking of characteristics? And for that, basically we fall back, for the testing part at least, we fall back to a system that we've discussed a couple of times, and that is our wonderful reproducibility and repeatability check, the R&R. Gage R&R can also be used to check things between humans. So when they don't use a measuring device, or maybe they use sort of a helper thingy to determine a value, the only sort of big problem, the limitation to Gage R&R studies in that way, using the Gage R&R methodology, is it has to be a continuous value. So for instance, if we are tasting something and let's say we're checking for the acidity, this is a nice one because we've got pH meters, pH, acidity meters. They are not the easiest mechanical chemical analysis to use. In fact, the normal pH meters, the quick thingies that you will put on an operator's bench, they generally they get quite a spread. But apart from that, we've got the meters. And if you really need to have a very precise answer, we've got nice titration options. You can get the pH really, really tightly. But that is not always the same as acidity for our human palate. So good thing for specifically the acidity parameter to use humans next to machines. Because let's put it the other way around. The pH tells you more about how to preserve food. And now we're going a bit deeper into food science, but the sour taste is not what preserves something like a yogurt or pickled cucumbers or stuff like that. There you really have the acid value, so that the pH is a more chemical way to describe how much acid is in the solution, and that is in the end what stops bacteria, not per se the sour taste. A good example of this is cola, which is a super acid drink. So it is more acid than orange juice, than lemon juice even. But there is so much sugar in it. In fact, there is more sugar in it if you're not taking sugar-free cola, but more sugar in it than in grape juice, for instance, or apple juice, which taste very sweet. Because both of them are in there, our tastes, they sort of neutralize it and make it into this full, rich taste palette that is not too sweet and also not that sour. In fact, many people like to put a bit of extra lemon in a cola. It affects the taste, yes, and that's why you do it. It will not really do anything with the acidity itself. So we've got this product, and we've got our people tasting it. And now if we say the acidity is good or bad, this is not continuous data. This distinct data, so really having yes or no answers or a couple of categories, there are statistical ways of also testing it. And there are ways in measurement systems analysis, so the bigger system under which Gage R&R also falls as a very important tool. There are different ways to check the quality of distinct data. For using Gage R&R, we do need a continuous thing, but a continuous does not have to be very precise. So if we take pH, this is a scale from, let's just say 0 to 14, with all the decimal places as possibilities. The sour taste will most likely be something like a 1 to 7 scale. So 1 is not sour at all, 7 is, oh my, that is sour. And where does it land? So where does our product land on this scale? And for this, you do need comparisons, right? So you're gonna train your panel, we'll get back to that as well, but you're gonna train your panel on what does the scale mean for us. But in the end, what you get is a trained panel, a number of people who can hopefully rate all of these products on the sourness scale. And let's say that they rate them relatively sour. So in this case, and when we do the full Gage R&R, we're going to have to completely cross it out. But A, B, and C, they all taste the cup that's sort of in front of them. They give it a 5, a 6, and a 5 for sourness. This by itself doesn't tell you a lot yet. If you have this in a normal sensory panel, you would either go for it is a 5 if you don't do any decimals, or you say it is a 5 and 1/3, so 5.3, because you take the average and note that down. The second one, I would say, is a bit better way of doing sensory, but it depends a bit on how you register it. But you see there is some difference. They're also quite close. What you, of course, want to do in Gage R&R is that you do not have everyone tasting at once, but you're gonna get it back to them a couple of times. So you're going to let everyone taste at least each cup. And if you know Gage R&R, you know we're going to add some numbers to it as well. But you're going to let everyone taste each cup, and now already it becomes a bit clear that, hey, there seems to be sort of a pattern evolving. Here we are simply checking who is tasting what from each product. If we want to test, are our human senses okay, we have to add this one extra important dimension, which is the repeatability for basically the same. So we're not going to label the cups the same, but we're going to give them each of the products again, 3 times, 5 times, a number of times without them knowing that we give what is the same product in the end. If we add a couple of extra numbers because we repeat everything 3 times, my apologies that it is probably already not legible, but now we get into the range and the repeatability specifically for each of the persons when they test again what is basically the same product. And we see that operator A, at least, not judging yet if they are correct or not, but at least they are very internally consistent. If you give person A the same cup, they will give you the same mark, which is something in any sensory analysis, whether it's a human sensor or a machine sensor, that is very important that we can see that. And they also always score the same at a higher level, this other product. For person B and C, we see some changes, some differences, and then we're going to compare. Can we actually use the people and what we see in our product? And with this type of data, we can do the normal statistical R&R analyses that we're sort of used to, right? That I've explained before on the channel, that you can find in different sources on the internet and in your Six Sigma handbooks. And you're going to compare how is the total score that we get for a product but also the differences that we see between the averages in our product. How does that compare to, can we reproduce the same results? So if we are today testing only with person A and tomorrow we'll be only testing with person B, are we going to get the same results? Now here, when we're testing with person A or B, we're keeping the same pattern. That is, person B has a more extreme way of measuring, so they're probably using the scale differently. Person C, we might have to have a chat with them, because it just seems that they are around a 5 whatever happens. The thing that the other testers scored higher, they scored slightly lower. So we see basically 2 problems popping up in our mini theoretical sensory panel, which is a discrepancy in how to use the scale and a problem. And why is this a problem? This could be because the person is just not very well trained. There's also a good risk that this person simply cannot taste sour in a good way. Now, those things, they bring us to how can we actually use and train human senses. See, that last thing I mentioned is generally one of the first things you want to do when you need a training program for human senses as well, and that means training people. So doing sensory training, making comparisons, doing an explanation of the scale, but also checking together with experienced tasters, really bringing people into the color profile of your paints, the taste profile of your food, the touch and feel of products that are maybe a bit squishy. I'm even thinking of, for instance, blacksmiths who know by the color of the iron or by spit, that is both blacksmiths and bakers, by spitting onto the metal or into the oven and how quickly does it evaporate. They know the temperature. This can be taught, but especially if we are talking about taste and direct use of your senses, some people are a lot better at that than others. And if people simply cannot really distinguish sweet from not so sweet or very sour from not so sour, they might not be suitable for your sensory panel. I mean, they're great people, but you need a sensory panel that you can trust. The other option is, of course, that you need to train them, and that is something you will definitely have to do with A and B. Internally, they are pretty consistent. They really seem to, be repeatable, so they reproduce their own results. That almost certainly means that you can train them because they are very consistent, and that means with them you need to go through opening up this data, comparing their tasting notes, and doing non-blind tastings or tasting together, doing corrections on the scale. If we assume that person A is, let's say, correct, because if we have 10 people in the sensory panel and almost everyone gets to basically those numbers, so on average it is a 5, a 6 and a 5, then we can say, person A, you are doing well, you are exactly as we expected. And remember, that is more important than the absolute truth. If we put this next to a pH meter again, not that important that you see the same range. We need to be reproducible. And person B, we can say, okay, this taste profile that you have, so these products, you put a 4, but really this is a 5 level, and you train and you give the feedback and you develop, in principle, a measuring device, right? But in this case, a measuring person, a human sensor. And with these types of training and comparing those notes, and this you do not do during the actual test sensory, but you can do it directly after. The reason why you don't do it during the actual sensory is because you want to have these independent data points. You want to be able to draw an average from a group of sensory testers that do not sort of push each other into one specific way, one specific grade. There is one experience I had with it, but you see it more often. The one was just very nice, where the director of the whole company was also in the tasting, and then there is this whole group around the table, and they all taste a bit, but no one says anything yet. And as soon as the director said, "Yeah, this one is correct on salt," everyone would say, "Yeah, it's correct on salt. Yeah, it's correct on salt. This one is too acid. Maybe we should do something about it." Everyone would say, "Yeah, it's acid. It really, you taste some acid, don't you?" So it was a complete confirmation bias towards the most important person in the room. It's a bit of a cultural thing, so to say. I mean, if you have such a culture in your decision making in management, you have a bigger problem than just your sensory panel. But it was quite a nice thing to see happening. You can also have, roundtable sensory where people really are honest and discussing a bit, and that can also really help your total decision making when somebody raises the, "Is this one a bit sour?" Other people say, "Well, yes or no," or I do taste this, or maybe something's missing. That can really also be effective. But in general, keep them separated afterwards. Make an average that will give you the best results in terms of reliability. And then, with this person B, you can retrain them. And that in the end is what you want. So you are much more interested in making sure that everyone gives you the same result for the same product, of course, and uses the scale, then that your scale is absolutely correct and completely matches up with a pH meter. Now, alternatively, in this case, you may, of course, say, "I would like my people to use the full extent of the scale. I do not expect my product to ever be not sour, but that means that to us, a 1 or a 2 is the sourness that you may expect from an apple, which is sour, but that to us is the minimum. That's the least sour our product is ever going to be. So if it is sort of mildly sour, give it a 4. Person B, you are doing that in such a good way. It's possible, right? That is based on how you want to train your sensory panel. But this is how you compare it. So yes, you can do Gage R&R on human sensors as long as the data is continuous, and continuous can still be with just following categories. You don't need to go into very deep decimals, and you need this and the comparisons to train after you have selected people whose senses are good as a basic premise. And indeed, especially in tasting, so especially when the mouth and nose are involved, there is quite a big difference between people. And we also know from the food industry that people who smoke a lot, usually their tastes are just worse, less reliable. So we generally do not select them for sensory panels. We also generally do not want you to take any strong foods or drinks at least an hour before sensory, so things like coffee. And like that, we go for a neutral palate with people who did not ruin their palate and have at least some innate ability to distinguish different flavors. And then you train, and then you get used to the product, and in the end you will get sensors that are as good, or for some units of measurement, a lot better than what machines can do, well, at least with the current standard technology. Now, tasting, that is the big example, but I will also guarantee you that some forms of looking at color, because if you make the color for other people, then very small, subtle differences may do a lot more to our eyes than a U meter would pick up. But also things like the firmness of a product and how it slides through the fingers, they can be very accurate. And for all kinds of tensile strength and gel strength, we have sensors, we have measuring devices. But in production, and of course safety is also a thing here. If it's molten lead or something like that, don't go put your hands in it, of course. But many products can actually benefit from quickly touching it or taking a sample and just feeling it, smearing it a bit, looking at it, smelling it. And that can be done by trained operators directly on the line. And we should not forget how powerful this quick sensory data and input can be. And in many applications, having well-trained people, the actual operators of the process, also trained in checking the product with their own senses, that can save you so much time. It can also mean that they will take the sample, do the analysis so much more frequently that you get a better control of your process. And that in the end, that is the goal. You want to have good products, but you mainly also want to control your process, because you do these type of tests to keep a certain process stability, a quality level, and get the same results you did yesterday again today, to detect if anything goes wrong in your process. So to conclude, can we use human senses in industry? Yes, we can, and we definitely should. And we should do it in a good and professional way. Now, if you like that small brand explanation, don't forget to hit that like button. Subscribe to the channel if you haven't done so already. And for now, I wish you the best of luck in training and using your human senses. But as always, also enjoy the improvement journey.